Alright, today we're going to be talking all about arithmetic sequences. We've talked about them a little bit in this last 4 pages. What is an arithmetic sequence?
It's
Adding or subtracting. Alright, the formal definition is a sequence in which the difference between the successive terms is a constant called an arithmetic sequence. The constant is referred to as the common difference. And we note this using the letter D. So can everybody please box that letter D right there? The common The common difference is just the number that you're adding by each time or subtracting by each time. To find the common difference of an arithmetic sequence, subtract any term from its succeeding term. To find the next term in the sequence, add the common difference to the given term. So if I give you this sequence right here, and I say, determine the common difference and find the next 4 terms. Why are you saying those are the answers? I mean,
going down by 5.
Do y'all agree it's going down by 5 each time? So if I subtract 5, Gavin's right, 2, -3, -8, and -13. This is the first question on your quiz next Monday. Now, if you just do this, you will get half credit. Why? It says determine the common difference. You need to state what is D. What is my common difference? -5. So don't forget to do both parts of that. But again, that's the first question on your quiz next week. Okay? Now, we've been talking about explicit formulas and recursive formulas. Each term in an arithmetic sequence is found by adding the common difference to the preceding term. Therefore, for the recursive formula, your equation, remember recursive formula, you need 3 things. Your equation is going to always be a of n equals the previous term, a of n minus 1, and what are you always going to do to it? Add or subtract your common difference. If your common difference is negative, then it would be subtract. Again, don't forget with the recursive formula, you also need your start, and what else do you need? The domain. I've been getting man, I cannot talk this morning. I've been getting asked a lot, why do we have to put the domain? What's the point of the domain? The point is so that you don't go backwards in a sequence. Does that make sense? If it starts at 1, you're not going to go find 0, a of -1, and -2. The point of this is saying, hey, I gave you a of 1, now the next one you need to do is 2 and up. That's the only reason for it. So this is your recursive formula. You would have a of 1, the equation, whatever your previous term is, plus D, and your domain. For the explicit formula, to find the nth term of the arithmetic sequence with the first term and common difference, you would use a of n equals a of 1 plus n minus 1 times D. This is your explicit equation. I want you to memorize this equation. Bless you. On the quiz, you can still do like you did on the quiz. You could say, hey, this is going by -5, -5, so it's going to be -5n, and then plug in to figure it out. But you need to memorize this equation because what if I don't have everything I want? What if I don't know what the D is? That's going to be the point of this equation. So, explicit and recursive formulas. Find both an explicit and recursive formula for the nth term of this sequence. What's happening in this sequence here? It's adding 9. So you do agree for my recursive formula, I need 3 things.
To be explicit, does A of 1 mean like you always have to use the first one?
Correct. And there will be a trick to that. I'll talk about it in a minute. What do I do? Say louder, sorry. A of 1 is 12. Is the first point. What's the next one? Thank you so much. Okay. Jackson. What do I do next? I could do the domain at the bottom. N is greater than or equal to 2. And again, 99% of the time that's going to be your domain. And then I need an equation. What's going to be my equation? It is your previous term, and we're adding 9. This whole thing right here is your recursive formula. For my explicit formula, I'm literally just going to plug into this equation. Okay? A of n equals A of 1 plus n minus 1 times 9. I think some of y'all knew this equation yesterday going into the quiz because a couple people used it. Great. But you need to simplify it for full credit. So what am I going to need to do? Distribute the 9. So that gives me 12 plus 9n minus 9, which gives me that is your explicit formula.
Does it matter if it's reasonable?
No, you could put 3 plus 9 in. That's fine. Yep. This is question 2 and 3 on your quiz next week.
So just put it on for
Correct. This way, you have a set formula, you use it, it works every time. Okay? Yes. Arithmetic. Only if it's adding or subtracting the same number. So arithmetic sequences have a constant rate of change, which say it louder.
Those two formulas?
Yes.
Like the very first thing?
Right. So it, like, for this one right here, we could find it, for example, A. We could find that because that's arithmetic. Right? But we couldn't do it on the other ones because they're not. They are either quadratic or exponential, geometric. So it won't work on that. It'll only work if it's adding the exact same number every time.
So how do you find
Is it because it's like
We'll do those next week. Yeah, we'll do those later. Right now, all we're doing is if you're adding the same number or subtracting the same number. All right, so let's get a little bit more complicated. How would I find the 68th term of this sequence? Are you going to want to do 68 blanks? Good God, I had somebody do that on a test one time. Please don't be that person. Okay, we're not. What are we going to do instead? Use the equation. So what's happening here? Minus 8. And please make sure both of them do that, because if not, then you can't use the equation. So it's minus 8. So that is my D value. Do you agree? What else do I know because of this sequence? A1 is 25. I know those two things. Can I now create the equation? Yeah. So A of n equals A of 1 plus n minus 1 times D. By the way, if your D value is a negative number, you need to have parentheses around it. Otherwise, I'll take off points because it looks like you're just subtracting 8. What do I want to know?
68.
I want to know where n is 68. So everywhere I see an n here, I'm just going to plug in 68. And please make sure you follow PEMDAS. Parentheses, exponents, multiply, divide. And this is where I said you probably need baby calculators. What is 67 times negative 8? Negative 536. So what is a of 68?
Negative 511.
Negative 511. And don't forget to label it with the correct notation. A lot of people got a point off because of that yesterday. Questions? All right, next one. This time I want to find what? The first term. This time I want to find a of 1. If the arithmetic sequence for which a of 25 equals 139 and d is 3/4, what am I going to do? Plug in everything I know. So I know the formula is a of n equals a of 1 plus n minus 1 times d. So this is going to be 139 equals a of 1 plus, what's my n here? 25 minus 1 times 3/4. Y'all solve for that, please. Look up when you're done, see if you got the same answer as me. Are we okay? All right, I want you to do the last one on your own. Go. Look up real quick just to make sure that was your first line.
Do we always need to write the formula first?
If you got it down, no. If you start messing it up, I'm going to require it correct.
Do we need to put the 38 minus 1 or can we just write 37?
You're more than welcome to write 37, yeah. Again, a lot of times I do things for notes just to make sure y'all are understanding my process. But yeah, I'm perfectly fine with you just going to that. What did you get when you subtracted them? Negative 18 what? 0.5? Okay. And you would divide it by 37. Is that 1/2? Nope. What is it?
Negative 1.
Thank you. Negative 1/2.
So we can use like both of these equations, recursive and...
Absolutely. The only time you're going to, like, truly, in this problem right here, if I would have asked you for the 6th term, just keep going and do it. When I ask you for a really high number, then you're going to use this equation. Right. And really the only other time you're going to use recursive is if, like, or if I ask you to create the recursive formula. So could I ask you now to recreate the recursive formula with this? Yeah, you have a of 1 and you have your d value. You can do that. Yep. Okay. That's really it for arithmetic sequences. Excuse me. I do want to do this problem right here because you are going to see this on your homework and your quiz. If two non-consecutive terms of arithmetic sequences are known, the terms between them can be calculated. These terms are called arithmetic means. In the sequence below, 17, 27, and 37 are the arithmetic means between 7 and 47. So arithmetic means are just your numbers between two numbers of an arithmetic sequence. So you are going to get a question like example 4 that says write an arithmetic sequence that has 4 arithmetic means between 4.3 and 12.8. So I'm going to have 4.3 first, and then what am I going to have between them? 4 blanks. 1, 2, 3, 4. And then I will have 12.8. And I want you to figure out what the sequence is. So how would you do that? Say it louder. Okay, super close. Why would I subtract?
Because you want to figure out how much it changed by.
Yeah, I want to know the difference from here to here, right? So to find your D, you are going to do 12.8 minus 4.3. What is 12.8 minus 4.3? 8.5. Now, you said divide by 6. Why did you say divide by 6? There's 6 numbers. Be careful. There are 4 spaces, 6 numbers, but if I were to do these little carets here to split up what I'm adding each time, how many carets are there? 5. You are going to divide by 5. Does that make sense? How many times are you going to count the difference between these? 5 times. So what is 8.5 divided by 5? 1.7. So you're going to add 1.7 each time. And let's say you did divide by 6. When you're adding it, you'll see that you did something wrong because you'll get there too quick. Does that make sense? All right, so what's 4.3 plus 1.7? Plus 1.7? Plus 1.7? Plus 1.7? And then does plus 1.7 give us back to 12.8? So you know you did it right. But this number right here is always going to be your number of blanks plus 1. Do I have any questions? All right, that's arithmetic sequences. That's about as complicated as sequences gets. Are you ready for series? Do you want to wait and do it tomorrow? No. Let's do series. What?
What's the difference between like a sequence and a series?
Okay, think about that. What is sequences?
It's just like adding and subtracting.
Right, but it's a
Line.
list of numbers. What's a series?
A collection of numbers?
What do we do to those numbers?
You multiply them.
What's a series? What? Not average because you're not dividing by it. It's taking all those numbers and adding them together. So remember last week or earlier this week, a series is a summation. You are going to find the sum of your sequence. So now we're still taking arithmetic sequences, but now instead of just listing them out, now we are going to do what? Add them. So actually here's a really good picture of the difference. We're now on page 7. An arithmetic sequence is -6, -3, 0, 3, 6. An arithmetic series is -6 plus -3 plus 0 plus 3 plus 6. So on y'all's quiz yesterday, a lot of people got points off simply because you wrote out the sequence, but you did not add them together. So you got points off because y'all were supposed to add on the back page. So just be careful with that. All right. So the sum of, so underline the word series on this one just so you know that's what we're doing in this page. We are dealing with series. It's the sum of an arithmetic sequence, the sum of a finite arithmetic series with n terms, or the nth partial sum of an arithmetic series can be found using these two formulas. I'm just going to go ahead and give them to you right now. Remember, when you see the letter S, that means sum. You should be adding things together. It is n over 2 times a1 plus a of n. You take your first term and your last term, and then you multiply that by n over 2. This you are going to use when you know your last term, when you know a of n. What if you don't know a of n?
Oh, you use formula 2.
You would have to use that formula we learned right here, this one, and you would plug all of this into a of n. When you do that, it creates formula 2, which is S of n equals n over 2 times 2a of 1 plus n minus 1 times d. This is when you only know n. You are going to have to memorize these two formulas. All right, after we use them a couple times, especially if you do the homework on your own, you should have the formula memorized. This one right here, or this second one right here, is just this top one. Look, all of this right here, all of this right here is just that formula we did on the other page.
Where does the 2 come from?
Because do you see how this one has a of 1? Do you agree this formula for a of n that we did on the other page had a of 1 as well? So that's how you get 2 a of 1s.
Well, why is it like n over 2?
Because whenever you're doing when you're adding them together like we did, let me see if we added together an arithmetic sequence. When you're adding them together over here, this would essentially take this first one plus this last one, and that's 18, right? And then how many are there right here? Does that make sense? Yeah. You're not going to need to know that. Yeah, just know the formula, but yeah. All right, so this one right here, how would we find the indicated sum of each of these? What do we know based on this sequence alone? Say it louder. A of 1 is -5. Does everybody agree in here A of 1 is -5? Cool. A of n is what? A of n equals 317. Okay, what else do I know? I'm adding how many? 7 each time. So I know D equals 7. What do I not know? I don't know N. Do y'all agree with that? I have no idea what N is.
You should use formula 1.
So I should, well, I can't use either of these. Actually, can y'all put right here? No, can we change this to only N? Because you have to know N for both of these because of the N divided by 2. Yeah. So this one you only use if you only know N. So I have to know N. How can I find N? Plug it into the equation we did over here. So that equation is A of N equals A of 1 plus N minus 1 D.
Why would you ever use formula 1 if you only need to know N for formula 2?
I'll show you right now after this. I'll show you that. Yep. So now I'm just going to plug in everything I know. I know A of N is 317. A of 1 is negative 5.
It's like faster.
Yeah, it'll be faster. Yep. I'm going to show you how you can do both and you get to choose. So if you know both things, if you know A of N, you can use either one of these, honestly. Do you agree I can add 5 right here? Are y'all okay with what I just did? And then I'm just solving. $47 is what I got. Be careful, a lot of people stop right here. Is my question asking what N is? No, what's my question asking? The sum. So, what Gavin was asking is like, why would I ever use this one versus this one if I need N for both of them? It's personal preference. If you don't ever want to memorize this one, you don't have to use it. You can just use this one straight up. So I'm going to use formula 1 real quick. I'm going to show you how to do this using formula 1. So we can do that. Yes. No, I used the first formula for this one. This is formula 1. So I still used what? Yeah, I used N over 2, so I did 47 over 2, and then A of 1, A of N. Does that make sense? Over here? What 2? It won't turn on. Wait, what 2? What are you talking about? Oh, this 2 right here. Where did this 2 come from? Yeah. Oh, so hold on real quick. This right here, A of N, I plugged this equation into this right here to get this. When I did that, do you already agree I have an A of 1 right here? Do you agree I have an A of 1 right here? So that's how I get 2 A of 1s. And then the rest is just the rest of that equation.
So this is the formula 1 is not really.
Yeah, these are equivalent formulas. So if you just want to, if you don't want to memorize 2 formulas and you want to memorize 1, this would be the formula to memorize. So I'm going to do the same exact thing with formula 2 right here. I'm going to do S of 47, 47 over 2. What's D? 7? So again, this one just takes a couple more steps in your calculator, but if it helps you to memorize just one formula, go ahead. And so forth. You get the same answer. And again, I'm showing every single step for your notes. You wouldn't be required to show every step like that. I'm just doing it so that you can see the process. All right, I want you to try B. You try B. Write down everything you know, then plug into an equation. I think I might leave the word problems for tomorrow.
Is B fine?
Is B what?
Is B fine? Oh, well, I was like, didn't even read that.
What did you ask? If it was.
Is it finite? So like,
Oh, yeah. Yeah, because it says the 28th. Correct. I see what you were saying now. N is 28. Yep. If I'm asking the 28th partial sum, N is 28. What else do I know? First term is 27. And what's happening here? D is negative 13. I have everything I need for what? The second formula. So I'm just going to plug into the second formula. And again, you need a parentheses around that negative 13. Look up to see if you got the same answer as me. Do I have any questions?
We don't have decimals for this test, right?
Nope.
So can we skip from like the very first line Can we go straight to the answer? Because it's just numbers.
So here's what I'll say. Because you don't get Desmos for this. Because you don't get Desmos, I'm going to ask you to show at least one line. Because what ends up happening is if you skip from here to here and you get it wrong, I'll have to count more points off. Versus if I'm seeing what your mistake is and I'm seeing, oh, you made a PEMDAS error, I can give you partial credit. Now, again, if you want to skip from here to here, I'm not going to stop you. It's just going to be more points off if you get it wrong. Does that make sense? Yeah. Okay. Can you start letter C? It's a little bit different. I think I'm going to stop here today. But this one is a little bit different because why? It's summation notation, but that's what we've been doing. We're still adding everything. But where does this start at? Everybody circle. That n equals 6 makes us start somewhere different. So, it's going to change what our n is. So, how would we find n? I just want you to think about it real quick while you're processing real quick. If I were to look at this, n equals 1 to 5, how many blanks would I have? 5. Do y'all all agree I would have 5 blanks? So with this one, how many blanks am I going to have? If I did 28 minus 6, it gives me 22. But that's not the answer. Because what if you did over here 5 minus 1? Would you do 5 minus 1 here? No, you would do 5 minus 1, and then you would add a blank, right? So the same thing can be said right here. If you're not starting at 1, you can subtract them. So I am going to do 28 minus 6. But I have to do what? Add 1. So my n is 23. Does that make sense? So let me say that again. If this was a 1 down here, do you agree it would be 28 blanks? Right, but 28 minus 1 is not 28. So you would add 1. 28 minus 1 is 27 plus 1. There's 28 blanks. So if it's not 1, you're going to subtract them, but then you need to add 1 to get your n value.
So if you just subtract them, that would give you the 22.
That would give you, yes, exactly. All right, what else do I know looking at this? Or what else can I find out looking at this? What else do I need to know? It's adding 5, so my D is 5. How did you get that? 5n tells me it's adding 5 each time. My D is 5. I need one more thing for this problem.
A of 1.
A of 1. But in this case, do I actually need A of 1? I need A of 6. How can I find A of 6? Plug it into your equation. What is 5 times 6 minus 17? 13. Now I have everything I need to do this. So go, plug it in. Look up when you're done.
Oh. I put the 2000
Do I have any questions? So again, did we ever really have to use this top one? No. If you can memorize the bottom one, you'll be good. You could, I just want to show y'all real quick. You could have used the top one on the one we just did. This is how I did it last year. I found A of 28 and then I plugged it in. It gave you the same answer. So you can use both. It doesn't matter which one you use, but if it makes it easier on your life to just memorize one of these equations, I would memorize that bottom equation. Okay? All right, tomorrow, the back page is just word problems, doing the same exact thing, so we'll do that tomorrow. You can start your homework if you want. It is not due until Monday, but it is 4 through 68 every other even, but you don't have to do 36 or 56. All right, but tomorrow we'll finish those word problems, and it'll be a homework day.
How much of it should we be able to do already?
Almost all. You could technically do the word problems because you've learned